So today Academic Dad is going to be teaching you everything on chain rule. Now we do chain rule when we have a composite function, that is function of a function. Okay. Now we've already solved this. We've solved this. But if you look at this right here, we have a couple of examples, and I will need us to go through this. So you also need to know, before we start, I need you to know that anytime you have the derivative of sine x, you'll find the derivative of sine x is the same thing as cos x. But anytime you see c, anything c, know that it will give you minus sign before the answer. So the derivative of cos x is minus sine x. Derivative of tan x is sec square x. Derivative of cotan or cot x, same thing as minus cosecant square x. So this is the same thing. Let me write it for cosec square x. The derivative of secant x is the same thing as sec x tan x. Derivative of cosec x is the same thing as minus cos x minus cosecant x minus cosecant x cotangent x. Now if you know this, let's try to solve these questions we have here. So the first one said, exercise 1 said y is equals to 4x plus 3 all cubed. And if y is equals to 4x plus 3 raised to power 3, we now do the first principle by saying let's u, I told you chain rule is used when you have an internal function and an outside function. An external function that you can differentiate inside, and you can still differentiate it outside. So if I differentiate, I can say let u be everything inside 4x plus 3, and let y now in this case be u raised to power 3. If I do this, that means that the u, I have u and I'm seeing x here over of the x, du dx is going to be, there's an invisible one here, 1 times 4 is 4, subtract 1 from the power, 1 minus 1 is 0, anything raised to power 0 is 1. So I have derivative of a constant is 0, so I have 4. Now for dy, and I'm seeing u of the u is going to be 3 in front. I taught you power rule. Go and check my video on power rule. Now subtract 1 from the power, so that I have this to be mean the same thing as 3u squared. Now the formula says that dy over the x, dy dx, that is y and x, deriving this, the derivative of dy dx, or the dy dx is going to be what I have for du dx times what I have for dy du. So if you check it, this and this can cancel, so that I have this 2, and this is the same thing as du dx is 4 times dy du is 3u squared. If I bring this together, it's the same thing as 12. Now what I have u, remember that u is equals to 4x plus 3 all raised to power 2. This is my final answer. Now let's go to exercise 2. It said y is equals to x squared plus 3 all raised to power 3. Now to solve this, we say let u be equals to everything inside the internal function, and let y be the external function, y equals to u raised to power 3. That is internal, all raised to power 3. That means that du of the x will be equals to 2x. Carry this and come as coefficient, subtract 1 from it, and the derivative of a constant is simply 0. Then dy over du, dy of du, dy du is going to carry this, come here, 3u, subtract 1 from the power 2. So dy over the x is simply du over the x times dy over du. So that if you do this, you now know that this is the same thing as 2x times 3u square. This is now the same thing as 6x u square. And this is the same thing as 6x. Remember that u is the same thing as x square plus 3. So let's put, this is our final answer. Now for exercise 3, it says y is equals to 5 minus 3x all raised to power 4. Now remember that the rule is let u be equals to the inside one, the one in the inside, then let y be u raised to power 4. So the u over the x, I'm seeing u and I'm seeing x, so I differentiate u in respect to x, is going to be equals to, derivative of a constant is 0, so I have minus, there's an invisible one, come here, 1 times 3 is 1, is 3, then 1 minus 1 is 0, so that I have just minus 3. Then dy, I'm seeing y, I'm seeing u, of the u is going to be 4, come to the coefficient, subtract 1 from the power, so that I now have that dy over the x, everything given to me, is equals to the u over the x times dy over the u. So this is the same thing as saying minus 3 times 4u3, and this is the same thing as minus 12. Now remember that u is the same thing as 5 minus 3x, so all cubed. This is my final answer. This is my final answer. Now I want to teach you the daddy's method. Remember I told you I have 1850 formulas for calculus. Let me give you the first one, the shortcuts. Now the first shortcut I'll be giving you is, let's take this example. Y is equals to 3x squared plus 7 raised to the power 5. Now first of all, look at this. Remember that your u is always the 3x squared plus 7, the one inside. Y is equals to u raised to the power 5 in this case. So what I just need you to do is derive the one in the middle, so that dy of the x, derive the middle term, derive the middle expression. If I derive this, it's going to be 3 times 2, this come here, it will be 6x, 2 minus 1 is just 1, and that is x. Derivative of a function of a constant is 0, so this is 6x. Now times, this is u, y is u, so I do carry this, come here, it becomes 5u, then subtract 1 from this, it becomes 4. So if I times it, is going to be 30x u4. So when I put it together, it's simply 30x, remember that u is 3x squared plus 7 all raised to the power 4. So your dy of the x, very simple. Look at this, look at all these steps, very simple. Now let's solve question 6. It's 20 questions, I'll solve 10. the 10 hard ones. You know, teacher will solve the hard ones. Student will solve the simple. Then I have y equals to root 2x cubed minus 1. In this case, all you just need to do is simply do y, in this case u will be equals to what you have inside, 2x raised to power 3 minus 1. Now notice that y here will be equals to u raised to power 1 over 2. Remember I told you that square root means half, cube root means 1/3. So this is the sentence as 2s cubed minus 1 raised to power 1 over 3. You must do this for you to derive it. Now if I've done this, I will now get this, I'll differentiate this, and differentiating this is simply the sentence as saying carry this, come here, I have 6x squared. Coefficient times is 6, subtract 1, 2, constant is 0. And if I know this, then dy of the x is equals, if I know this, half come here is going to be 1 half u, half minus 1. So this is the sentence as saying, let's do this way. It's then 2 into 2, 1. So I have 1 minus 2 into this, 1 into 2, 2. Then this minus 2. This is sentence as minus 3 over 2. So if you know that this is now the sentence as 1/2 u minus 3 over 2 times 6x squared. So if you carry this and times, when you times this 2, now that dy of the x is the sentence as saying 3x squared u minus 3 over 2. Are you kidding me? Are you kidding me? I thought there was a minus here. This is going to be 1 minus 2 is the sentence as minus 1. May God no punish devil. Minus 1. Minus 1, please. Look at it. 1 minus 2. Sentence as minus 2 plus 1. So minus 1 over 2. So this is the sentence as, if I have this to be 3x squared, this is the sentence as times 1 over u all raised to power half. If you know, you know. And you know that this is the sentence as 3x squared all over u 1 over 2. And this is the sentence as 3x squared all over root u. And remember that u is something. So this is dy over the x, dy over the x, dy over the x, dy over the x. So remember that u is equals to something. So this is, so u is equals to, you should remember, 2s cubed minus 1. So this is our final answer. So for number 7, said y equals to 2 over x raised to the power 4 plus 2 all cubed. Now if you know this, remember that u is going to be equals to the one with internal function x4 plus 2. y will be equals to u all raised to power 3. And in this case, notice that there is 2 up here. There's 2 up here. So this is going to be the sentence as 2 u raised to power 3. But let's continue first. So first of all, you need to know that this is the sentence as 2 all over. So is the sentence as 2 over 1 times 1 over x4 plus 2 cubed. And this is the sentence as 2 times x4 plus 2 raised to the power minus 1 is the same thing. So if you know this, okay, raised to the power minus 1 times 3, because there's 3 here. So this is the same thing as minus 3. So if you know this, it simply means that y here is equals to u raised to the power minus 3. So let's derive this. You know that the u of the x will simply be 4x raised to the power 3. Subtract 1. Constant. Derivative of a constant is 0. Then that dy of the u here is going to be minus 3, come down, u, minus 3 minus 1. Subtract 1 from the power. So this is going to be minus 3u minus 4. So if you know this, it simply means that now this means that dy dx is going to be du all over dx times dy all over du. So this is the same thing as saying bring what you have. Now remember that there is 2 given to us there. So bring what you have, and in this case it simply means that our y is going to be, this means that our y is the same thing as 2, sorry, first of all, our y here is supposed to be everything about 2 times u raised to the power minus 3. This is what our y is supposed to be. Looking at this, because this is u raised to the power minus 3 and there's 2 in front of it. So this is the same thing as 2 times minus 3 u u raised to the power minus 4. Now bringing this du over the x is 4x cubed times dy over du is 2 times minus 6 is minus 6 u raised to the power minus 4. When I times this, I'm simply going to have that this is the same thing as 4 times 6 is 24x cubed, and is in a negative, is in negative, then u raised to the power minus 4. So this is the same thing as minus 24x cubed, u is equals to x. Remember that we said let u be x raised to the power 4 plus 2. 4 plus 2. Then all minus 4. Believe me that this is the same thing as minus 24x cubed times 1, if you remember, times 1 all over x to the 4th plus 2. So this is the same thing as minus 24x cubed all over x to the 4th plus 2 all raised to the power 4. These are final answers. So I want you to take your time. And go through this. In our next class, I'll teach you everything about differentiating using chain rule for trigonometry, differentiating trigonometric functions using chain rule. So thank you very much.